Hi, welcome to AB Video 2.3D Part 2, Product and Quotient Rules Graphically, and More Rates of Change.
Okay, numbers 81 and 82, very popular on the AP is for them to give you graphs. I've tried to emphasize the X and Y axes. They made them gray for some reason. Okay, it says let P of X equals F of X times G of X. This is a product rule. Let Q of X equals F of X divided by G of X. That's a quotient rule. They want you to find P prime of 4 and Q prime of 7. Now, of course, they're not giving you the actual equations of F, G, P, or Q. All they're giving you is a graph. So here's the graph of F, the dark black line, and the graph of G is this gray thing. And they both look like piece functions, right? Okay, so if we want to find P prime of 4, if you remember what that means, it means the slope of the tangent line to P of X at X equals 4. So let's start by finding P prime of X using the product rule. So P prime of X, I guess that's on the next page. Yeah. Okay, I've redrawn this over here and actually labeled some points. So, P prime of X using the product rule is F of X times G prime of X plus F prime of X times G of X. Therefore, P prime of 4, which is what they're asking for, let me move this over a little bit, is F of 4 times G prime of 4 plus F prime of 4 times G of 4. So now we go over for all 4 of these values, we have to come over here. So F is the red graph. If you look at the actual grid that they gave you on the previous page, you can see that that's the point 4, 1. So F of 4 is 1. G prime of 4, here's the G graph, here's G at 4, but they want G prime of 4, which is the slope of the tangent line to that green graph at the point 4, 8, and that slope looks to be like it's 0. F prime of 4, at 4, they want the slope of the tangent line to the curve. Well, it's actually not a curve, it's just a line, and that line has the same slope everywhere. If you picture that bug traveling along that line, its little matchstick is going to have the same slope as that line. So you can find the slope between any 2 of these 3 points that are on that little segment. And I happen to have picked these, I think, what did I pick? Yeah, these 2 points. And then G of 4, if you look on the graph of G, you'll notice the coordinate of G of 4 is 8. And then you just simplify that. Okay? Same thing for the second one. They want Q prime of 7. Q of X is F of X over G of X. So we do a quotient rule. Then we replace all the X's by 7. And then we go through the same procedure for G. What's G of 7? What's F of 7? And what are the derivatives of those quantities? And you can go back and look at that if you'd like. Okay, number 84, the radius of a right circular cylinder is given by the square root of t plus 2, and its height is 1/2 of t, where t is the time in seconds, and the dimensions are in inches. Find the rate of change of the volume with respect to time. Before you do anything else, as soon as you see it's a geometric figure, draw the geometric figure. You know that this is the radius of the base, and that's the height. They're looking for a derivative. It's the rate of change. It doesn't say average, so therefore it's the instantaneous rate of change, which is the derivative. And you know it's the derivative of the volume with respect to time. You are looking for d dt, the derivative of the volume, that'll be in the numerator, with respect to time, that'll be the denominator. So what you need is an equation that relates the volume and the time, and then you'll take the derivative with respect to time of both sides. Okay? So of course you should know the formula for the volume of a cylinder. If you do not, think of it as filling up this cylinder with paper plates. The area of each paper plate is the area of the circular base, which is pi r squared, and the number of paper plates you would need to fill up this container would be h, so it's pi r squared times h. Now they told you in the problem that the radius is root t plus square root of t plus 2, and they told you the height is 1/2 root t, so we simply plug those in. Now of course when you square the square root of t plus 2, you just get t plus 2, and just going to simplify it a little bit. I'm going to say pi times a half is pi over 2. That's root t. While I'm at it, I'm going to avoid a product rule. You could do a product rule, but you could easily call this t to the half and distribute. And then you get pi over 2 times parentheses t to the 3 halves plus 2t to the halves. Now we're ready to finally take the derivative with respect to t of both sides. You can see on the left that what you have is dv over dt, which is what you're looking for. And on the right, sure enough, we're taking the derivative with respect to t, which is the variable that we have. I pulled out the constant pi over 2, and then I take the derivative of each one. After that, it's just a question of factoring out the t to the negative a half to get it to look like the answer in the back of the book. And of course, you're pulling out the t to the smallest exponent, and you're asking yourself, negative a half plus what gives positive a half? Of course, negative a half plus 1, which we don't bother writing t to the 1. And the units of measure, this is volume. Remember it said that the measurements of the lengths were in inches, so the volume is in inches cubed, and they told us that the time unit of measure was seconds. Okay? And again, don't do a product rule on 4 times x squared. It's just 8x to the 1. Here what I did, I found a common denominator here. That's 3t plus 2 all over 2. And then you can look at it as I multiply the big numerator and big denominator by 2. So it could look like this in a multiple.
And that's the end of video 2.3D, part 2.